Hey guys, it's off1 here, and today we're going to be solving container with most water. In this problem, we're given an integer array height of length n, and in this problem, each index represents a line that, when drawn, has the endpoints I0 and I of height I. So for example, let's say we start at this point here. Let's just call that index 0, and the coordinates would be 0, 0, and 0, 1, because that would be the height of this one right here. And then in this problem, what they want us to do is find two lines that together form a container, and that this container contains the most water. And in the end, they want us to return the maximum amount of water that a container can store. So for example here, let's just take these two lines, for example, this one and this one. Then the max water that can be contained here is just here, because we can't have water that goes all the way up to here. So basically what's happening here is that we're forming a container using the minimum of the two heights. So if we know we're going to be calculating area, let's just get our formula. So the way to calculate the area for rectangle is length times the height, and our height is just going to be the minimum between bar number 1 and bar number 2. Let's say we're doing the first and second index. So let me just write that down here. Height is equal to the min of our bars. And for length, what we're going to do is calculate the distance between this point and this point. So for this example here, we're only doing one jump, and that means that our length is going to be 1. And if we were calculating these, that means we were doing 2 jumps here, which would make our length 2. So our length is going to be the distance between our lines. So now that we have that, we can just write this into some pseudocode. So our actual code would look something like this, where the index of the second bar minus the index of the first bar times the minimum of the two heights is going to give us our area. So let's say this is our first iteration, this would be I, and let's say we're checking the height of this one, this would be J. So now that we know how to calculate the area, let's see if we can think of a solution. The brute force approach would be to just take the first iteration and check each number in the array and keep track of the max that way. And then once you're done going through the array once, you do it again for the next number and then check, for example, 8 times 6, 8 times 2, 8 times 5, and then you do that for every single element in the array and update the max as we go. But the problem with that is that it takes O of n squared time, and this problem can actually be solved in linear time. Instead of going straight into the O of n solution, let's explore this O of n squared solution and see if we can get to it from here, because I feel like that would be more useful than just telling you the answer. So to start, our first loop is iterating from 0 to the end, so our I would start here, and then for our J, we will start at I plus 1 all the way to the end, and for each time we're iterating through J, we want to find the area. So our J will start here. Now I'm going to write the result of the for loop out, and then we can analyze them to see how we can optimize our search. And here are the results. So for I equals 0, we see that we start here at 1, and then our J will be initialized to here, pointing to 30. So according to our area formula, we do J minus I times the min of both heights. So for here, we do J, which is 1, minus 0, times the min of 1 and 30. And the min of 1 and 30 is just 1. So we can see that we didn't even use this 30 for any of these calculations because we're bounded by our lower bound. So what does this tell us? Well, we can see here that our max is 3, and that comes from looking at these edges. So maybe a smarter approach would be to start by calculating the area for the first and last index, and then working our way inwards. So let's try that. Here I've written a new example that contains different numbers, and like we said, we're going to start by calculating the area for these two, and the way that would be is this is index 0 and this is index 3. So our formula would be 3 minus 0 times the min of 3 and 4, which is equal to 3 times 3, which would be 9. So now, which pointer do we want to move? Like I said earlier, we are bounded by our lowest number, so we want to move this 3 pointer to be pointing to 10. So we can just do that here, and then this would be the first index, and then now we calculate our area again. So index 3 minus index 1 times the min of 10 and 4. Well, now our min is going to be 4, and this is going to be 2. So we have 2 times 4, which would be 8. And then now we want to move the pointers again. Well, this is now our bigger number, so we want to move our lower bound, which will be this. So now this pointer would be moved to here. And then now we can calculate this area. So we would have 2 minus 1 times the min of 10 and 13, which is equal to 10. So now we can see that this gives us the correct max height, and that this is the algorithm we can work with. So let's just summarize what we learned here. So we know we want to initialize a pointer over here for our left point and a pointer over here for our right point. And the way we want to move the pointers is by seeing which of these points to the lowest number. So in this scenario, left would be moved to the right by 1 because it is lower than 4. And then after calculating the area between 10 and 4, then we want to move our right pointer to the left because we see that 10 is greater than 4. And at this point, we would stop iterating because we don't want our left and right pointer to be put into the same spot. So basically, we want to loop while left is less than right, and if left is pointing to a value that is smaller than the right, then we want to move our left pointer to the right, because we know that having a lower value does not help us get a higher area. And we want to move our right pointer to the left if right is pointing to a lower value. So our code would look something like this here. And what we managed to do now is reduce these two for loops to just a while loop using our two-pointer method. And the way the while loop is going to work is we find the area first, and then we check which of these has the lower number, and we update the pointer accordingly. But what happens in a scenario where nums of left and nums of right are equal? So here I've written an example that will probably help us solve this case. So I've already done the area for this first iteration where left is at the leftmost point and right is at the rightmost point. And we can see that the area is 3. But now let's try and move our right pointer to the left one because we're trying to figure out what happens. So if our right pointer is there now, we want to calculate our area, and we see that this is equal to 2 now. So we didn't really get a bigger number, so let's just try and move them the other way. So our right pointer is now pointing to 1 again, and now we're going to shift our left pointer to see if that makes any difference. And the area for this would be 1. And we can see that it doesn't really make a difference which pointer we move, because in the end both pointers are going to end up pointing to 4 and 6, and if we calculate the area for that, we see that we get a new max area of 4. So what this lets us conclude is that it doesn't matter which pointer we move. So for our example, we can just cross out this condition and just move the right pointer to the left one. Now that we finish our pseudocode, let's get into the real code. To start, we just want to initialize our left pointer to be equal to 0, and our right pointer to be equal to the length of nums minus 1, or I guess it's height in this problem. And additionally, we want to initialize a global max, and this is how we're going to keep track of our maximum area. And we're just going to start with 0 since we're promised in a problem that we're not going to have any negative numbers. And then from here, we just do what we did in the pseudocode. So while left is less than right, we want to calculate the current area, and from here we're going to use our formula, so right minus left times the min of height of left and height of right, and this is going to give us the current area for whatever we're pointing to. And then from here we just want to check if current area is greater than our global max. We just want to update our global max to be equal to our current area. And once that's done, all we want to do is check if height at the left is less than height at the right. This means that our height at the left is smaller, and we want to shift that because there's no use in using that anymore. So left is going to increment by 1. Otherwise, we just want to decrement our right pointer. And that's pretty much it. After that, we just want to return our global max, and that should work. So as you can see, this solution is pretty efficient, and now we'll step through the code manually. So to start, we just want to initialize our pointers and our variable to keep track of the max, which I've done here and named it max. And our variables for left and right are initialized to 0 and 8. And I'm just going to write them here just so we can see them a little clearer too. So now we want to do while left is less than right, which it currently is. We calculate the area using right minus left and the min of whatever the height we're at. So for this current one, we have 7 and we have 1. The min between those two is just 1, and right minus left is 8. So our current area is 8. And we see that the current area is greater than our global max, so we're going to update that as well. And now we check. Is the height at left less than the height at right? Yes, because 1 is less than 7. So now we just move our left pointer to the right one. And now we start over. Our current area is now going to be 8 minus 1 for right minus left, and the min height is going to be 7 because 8 is greater than 7. And so now our area is going to be 7 times 7, which is 49. So our current area is now 49, and that's greater than our global max as well, so we're going to update that. And now we check. Is the height at left less than height at right? No. So we want to decrement our right pointer by 1. Now we go to the next iteration. Current area, right minus left, which is, let me update this as well, 7 minus 1, and that will give us 6. And the minimum between 8 and 3 is 3. So we would have 6 times 3, which is 18. And that is not greater than our global max, so we're not going to update it. And now we check. Is the height at left less than the height at right? No, because 8 is greater than 3. So now we decrement our right pointer by 1. And now we calculate our area again. So right minus left would be 6 minus 1, which is 5. And we multiply that by the min of the height of left and height of right, which would be 8. So it would be 5 times 8, which would give us 40. And now we check. Is our current area greater than our global max? No, because our current area is 40. So now we just go to the next if statement. So if height of left is less than the height of right, which is not because they're equal, and like we mentioned, it doesn't matter how we decrement our pointer. For this code, we just decrement it the right by 1. So I'm going to do that. So now our right pointer is here. And now we do this code again. Current area is equal to right minus left, which is 4. And we multiply that by the min of 8 and 4, which is 4. And that will give us 16. And that is not greater than our max height, so we're going to check if height of left is less than the height of right, and it's not because 8 is greater than 4. Now we just shift our right pointer to the left one. And now we check the area again. Right minus left, that will be 3, and the min between 8 and 5 is 5, and that will give us a current area of 15, and that is not greater than our global max. So now we just check. Is height at left less than the height at right? No, because 8 is greater. So we just decrement our right pointer again. And now we have current area is equal to right minus left, which is 2, times the min between 8 and 2, which is 2. So our current area is 4, which is not greater than our global max. So now we just check where we move our pointer. Height at left is not less than height at 2. So we just decrement the right pointer by 1. And now we do our last check. Current area is equal to right minus left, which is 1. And the min between 8 and 6, which is 6. And this will give us a current area of 6, which is not greater than our global max. And now we just shift our right pointer to the left one again. And since our pointers are now equal, this while statement exits out, and we return the global max, which is 49. And that is true because that is one of the examples we had. If this video helped you in any way, don't forget to like and subscribe. Thanks for watching, and I'll see you in the next video.